Okay, I'm going to solve two quadratic equations in three different ways. So the quadratic equation is in the form ax squared plus bx plus c. And I'm going to do it in the first way is factoring, second way completing the square, and the third way the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So the first equation, I have one here and one here. A is 1, so it's x squared plus 7x plus 12 equals 0. So first way is factoring, and the way that is going to be two factors. So this one times this one equals 0. And then the easy way to start this is to always just start each one with x, and then figure out which one added together to get 7, and then multiply together to get 12. And then this one's fairly easy, so you can see it will be plus 3 and plus 4. And then, so either one of these multiplied together will be 0. So either x plus 3 equals 0, or x plus 4 equals 0. So that means x equals negative 3, or x equals negative 4. So that's the two answers. So that's factoring. Completing the square is you take b and you divide it in half and you square it. So 7, divide it in half and then square it. And then the next thing you do is you add it on both sides, or you actually plus and minus in the equation. So what I'm going to do is take it and then plus 7x. I'm going to do each step. First of all, let's say 49 over 2, or 4. 7 squared is 49, and 2 squared is 4. So I'm going to add it. This pen is not good here. And I'm going to subtract it. And that equals 0. So then, take x squared plus 7x. And then I'm going to keep the 49 over here. Over 4, I mean. Then I'm going to subtract 12 on both sides. And I'm going to add the 49 over 4 on both sides. Okay, so this is completing the square. That's what this means. So this means I can complete the square here. That's why I did this divide in half and square it. So I could get this 49 over 4. So now I can take this and it's squared, but this I have to then take the square root of it, which is 7/2, which is what's in here. And that equals negative 12 plus 49 over 4, which I'm going to start reducing here. So I'm going to take 12 times 4, 4, and then over 4, plus 49 over 4. And then that equals 8. Actually, that's negative. So that's negative 48 over 4 plus 49 over 4, which I'm going to say equals 1 over 4. Then I'm going to say, I'll just write it down here. X plus 7 halves squared equals 1/4. So then I'll take the square root on both sides. So then x plus 7 halves equals plus or minus the square root of 1/4. And then x plus 7 halves equals plus or minus 1/2. Then x equals, I'm going to subtract 7 halves plus 1/2 minus 1/2. So that equals negative 7 halves plus 1/2, or negative 7 halves minus 1/2. So then this will be negative 6 plus 1. Oh, I'm sorry, negative 6 over 2. Or negative 8 over 2, which is negative 3, or negative 4, which is what you got here. So, same answer. So that checks out. Now if I do it the third way, completing the square, I'll take negative b, which is negative 7, plus or minus square root of b squared, which is 7 squared, minus 4 times a, which is 1, times c, which is 12, all over 2a, which is 2 times 1. That equals negative 7 plus or minus 49 minus 48 over 2. And that equals negative 7 plus or minus 1, or 49 minus 48 is square root of 1 over 2, which equals negative 7 plus or minus 1 over 2, which equals negative 7 plus 1 over 2, or negative 7 minus 1 over 2, which equals negative 6 over 2, or negative 8 over 2, which equals negative 3, or negative 4, which is the same as we got before. So you can see all three methods work this to get the same answer. And I can just highlight this here to say the same thing. So what we'll do is just for practice is do it again with another problem. This one's a little bit more complicated because it's got a not equal 1, a equals 3, so a little bit more tricky here. So using factoring here, a little bit more guesswork, but we know that to get the first one it has to be 3, and it's got to be x for both, because x squared's got to be the first one, so it's got to be 3 times something equals 3. It's a prime number, so it's going to be 3 times 1 more than likely, so we'll put 3 and then leave that alone, 1, so 3x squared. 8, whatever here and here has got to add to multiply together to be 8. So, and then whatever this term and this term will have to be 14. So let's say minus 2 and plus 4. Or I'm sorry, minus, because it's got to be, this has to be positive, so this will be negative 4. So this negative 2 times negative 4 is positive 8. and then negative 2x plus negative 12x is negative 14x, so that works. So this is your factoring. It takes a little more trickiness, but it works. So then let's see, this equals 0, so that means either this is 0 or this is 0. So let's say 3x minus 2 equals 0. Then that means 3x equals 2. That means x equals 2/3. So that's one answer. And then if x minus 4 equals 0, that means x equals 4. So here's your two answers. Then completing the square is a little tricky because it only works if this term is where a is equal to 1. So, but the thing that's nice is 3x squared minus 14x plus 8 equals 0. I can divide by 3 all these terms, and I still have the same, it doesn't change the equivalency, so this cancels. This is still 0. So I end up with x squared minus 14/3 x plus 8/3 equals 0. So now I can do completing the square. And then I can take 14/3 divided by 2 and square it, which is 14 squared over 6 squared. And that I don't have to do it now because I did it before, is 196 over 36. And then we can take, we just stick with this formula here then. X squared minus 14/3 plus 8/3 plus 196 over 36 minus 196 over 36 equals 0. And then I'm going to do a couple things at once. I'm going to move the 8/3 over on this side. I'm going to move the negative 196/36 on this side. So I'm going to get negative 8/3 plus 196/6, and I'm going to have x squared minus 14/3 x plus 8/3 on this side. Oh, and no, that's not right. 196 over 36. Because I need to square this. So then I'm going to square this side. X minus 14/3 6. That's my 14/6, sorry. Because I'm going to square it to get this one. Equals. And then I'm going to get a common denominator for 36, I'm going to multiply top and bottom by 12. And this happens to be negative 96 over 36 plus 196 over 36. And this happens to be 100 over 36. So then, if I take, let me just write it back down again so it's a little more clear. Equals 100 over 36. So if I take the square root of both sides, I get x minus 14 over 6 equals 100, square root, sorry, of 100 over 36, plus or minus. So then, luckily both of these square roots are easy to do. So it's plus or minus 10 over 6. So then I'll I'll add negative 14/6 on both sides, so equals 14/6 plus or minus 10/6. And then that is 14 plus 10 over 6, and then 14 minus 10 over 6. Oops, that's not a 10. Okay, so then this is 24 over 6, or 4 over 6, which is 4 or 2/3. And that's the same as I got here. Now, run out of room here, but it'll be pretty quick because let me just do it in a different color. I can actually use the original formula just to be tricky here. Negative b would be, let's see, it'd be positive 14 plus or minus square root of, oh, that's not going to work. That's pretty, I guess I could, I hate to erase this, but I'm going to erase this. Plus 14 plus or minus b squared, which is 14 squared, actually negative 14 squared, which is just 14 squared, minus 4 times 3 times c, which is 8, all over 2a, which is 3 times 2. That is equal to 14 plus or minus 14 squared is 196, minus 12 times 8 is 96. And you can start to see the same thing develop as down here. 14 plus or minus the square root of 100 over 6 equals 14 plus or minus the square, well, 10 over 6, which equals 14 plus 10 over 6, or 14 minus 10 over 6, which equals 24 over 6, or 4 over 6, which equals 4 or 2/3, which is the same thing. So you can see quadratic equations can be solved actually more than 3 ways, but this is the 3 main ways you can solve them. This is the brute force way. Sometimes you can't solve them all 3, but these 2 problems you can solve them the 3 ways, and I picked these on purpose so you could solve them the 3 different ways. So I hope these 2 examples are helpful to see that the methods used. So see you in the next one.